So you guys, we're on page 31 in our packet, and I wanted to review with you the angles related to circles notes from section 10.5. It sounds like you guys all did a really good job teaching yourself these angle relationships. Remember that the book gives an excellent explanation on page 472. You could use that to do the homework from last night. The first three on page 30, we already knew that the central angle was equal to its intercepted arc, and we already knew that the inscribed angle is equal to half its intercepted arc. So what I did here is I just marked my arc in pink, and I'm going to mark this in pink over there. Color coding on these first ones is not going to make that much of a difference. And then the only new part that we learned on this page is a tangent chord angle, which also has the vertex on the circle and is half its intercepted arc. So an inscribed angle and a tangent chord angle have that in common, that the vertex is on the circle, therefore it's half the intercepted arc. Alright, here's where the color coding is going to become awesome. Alright, so for the vertex inside, but not at the center, it's a chord angle. And what I did is I highlighted AB in pink here, and I highlighted in pink over here. Same thing for DC, I put DC in blue and blue. And for a chord angle, it's half the sum of the arcs. When the vertex is inside, it's half the sum. Now for the rest of these, the vertex outside the circle, it's half the difference. The angle is half the difference. Now you're not always looking for the angle, so it's important that you save that relationship in your head. The angle is half the difference of the arcs, because sometimes you'll be given the angle and you'll have to work backwards using algebra to solve for the arcs. So in each of them I made AB, or in this case ACB, pink, and then I made the smaller arc in blue and color coded it just for fun. So whenever the vertex is outside the circle, the angle is half the difference. When the vertex is inside the circle, it's half the sum. If it's on the circle, it's just half the arc. Now, these problems aren't difficult to do, but if you don't memorize the relationships correctly, then they become impossible. So if you make a note card for each one, if you make a flip book, whatever way you like to memorize, treat this like memorizing vocab. You need to memorize the formulas. All right, let's look on page 33, please. And let's do some of these practice problems. Turn the page. Now, on number 1, they gave us that this arc was 20, and they gave us that from here to here was 104, and that from here to here was 156. They want us to find the measure of angle C, which is an angle outside, so it's going to be half the difference of the intercepted arcs. But they did not give us this arc here that I just marked in yellow. How can I find the measure of that arc before I start my problem? Phil?
104 plus 156 plus 20.
Good, so we're going to add all those up. And why would we add them all up? Ah. Perfect. So this adds up to how much? 280. Then we take our 360, we minus our 280, and we get 80. So that means this part here is 80. Now we could use our formula. So, Joel, can you tell me what the measure of angle C will be equal to?
Oh, it's 30.
Well, how did you get that? Walk me through it.
Oh, 80 minus 20 equals 60 divided by 2 is 30.
Good, so I can write 1/2 80 minus 20. And I like to set it up like that because sometimes the arcs will be where the x is at, and you want to practice writing the equation. So the measure of angle C is going to be 1/2 of 60, or like Joel said, 30 degrees. Great. Now, number 2 asks us for an angle that's inside, so it's a chord angle. But notice that we do not have its intercepted arcs. We have no information about those two arcs. So So what we're going to do, we're going to call this angle x, because we do have information about its intercepted arcs. We have, this one is 63 and this one is 25. Now if I go through the trouble of finding x, how can I find y afterwards? What must the relationship of x and y be? Ruby? They're supplementary. Good. So let's go ahead and find x. Now the measure of angle x, oops, is going to be 1/2, what? The difference or the sum? The sum. Good. Of 63 plus 25. Add them up. What do we get?
43.
So we get half of 88. Oops, I did 2 steps. So the measure of angle x is 44. So if angle x is 44, then angle y is how much?
36.
Good. All right. Who could tell me how to set up angle number 3? Angle outside. Ian.
Wouldn't you just do 227 minus 133 divided by 2?
You would. So the measure of the angle would equal 1/2 the difference, 227 minus 133. And I know it seems like extra work to write it out like I do. Like I've been saying, I do that because this last problem you're going to see, we're not looking for the angle. All right, Katie?
Is that a tangent-tangent angle?
That would be a tangent-tangent angle, but what's important to note is that the vertex is outside. When the vertex is outside, it's half the difference. So what do we get?
73 plus 67.
What do
It's
we
like
get?
140.
No? You weren't actually doing the problem? I see some calculators. Yes. Nikki?
Well, if 1/2 of 194.
1/2 of 194? I don't think so. No, half of 94. Yeah, so 47. Wow. It's early. It's Monday. It's okay. Oh my gosh. So all along I've been saying it might be helpful to write it out as an equation because we're not always looking for the angle. So here is a problem just like I've been talking about. 68 degrees is the angle. This angle happens to be inside the circle. So is it going to be half the sum or half the difference? Half the sum. So remember, the measure of the angle is going to be 1/2 the sum. So the angle is 68. It is, or equal sign, 1/2 of x plus 18. You should practice writing it out because sometimes they're not asking for the arc, or sorry, sometimes they're asking for an arc rather than asking for the angle. Now, your algebra steps here, I think it's easiest to cancel the fraction instead of distributing it. So I'm going to multiply each side by 2 first and get rid of the 1/2. When I do that, I get 136 equals x plus 18. When I multiply each side by 2, the fraction goes away. Yes?
Do you not do 2x plus whatever that is?
Yeah, when I multiply this by 2, that cancels. That's the purpose of multiplying each side by half. Okay? Now subtract 18 from each side. You get 118 equals x. All right, so number 4, we'll preview some problems that you'll have to do in your notes. on your homework. All right, good job.
Is there going to be something like that on the test?
Really scary.